This is RD Sharma Solution, Class 12, Chapter 18. Maxima and Minima exercise is 18.2. Now this exercise, this is based on the first derivative for local minima and maxima. So first understand this, that there is a curve like this. Okay. Now this is the highest point, let us mark it as plus, and these are the lowest points or low point which are lower than the surrounding point. Now if you go from positive to negative, that means you were on the positive, you were on the height and you came down. So when you move from positive to negative, that means you were on maxima. Now from negative to positive, if you move from negative to positive, that is from a part which is below to a part which is higher, from negative to positive. Okay, you are calling it as y is fx. Then you are at minima. So y equals to fx, first thing we'll do is the differentiation dy by dx. You can call it as f dash x also. The second step will be, we will put it as 0. dy by dx is equal to 0. So you will get some critical points. Those critical points will tell you whether these points are point of maxima or minima. That is, if you have certain points, say a, b, we can add more of them. But on the number line, if it is negative infinity to infinity, there are three intervals. You got, when you put dy by dx equals to 0, you got two critical points, for example. Because when you put a and b in this dy by dx or f dash x function, we'll get 0. So we'll take a value which is lower than a, and we'll see what will be the value of f dash x, not fx, f dash x. So for example, it came as plus. Any value which is between a and b gave you negative, because you can take any value between a and b also. Now that can give you some value of f dash x. It may be positive, it may be negative. So you got a negative. Then anything which is above than b, that is, if you say the function became plus, let us mark one more value c. So when we go from positive to negative, this point A is the point of maxima. When you go from negative to positive, this point B becomes the minima. But when you go from plus to plus or negative to negative, that means this is called the point of inflection. What does it mean? It means that nothing is increasing, nothing is decreasing. Neither increasing nor decreasing. So this is how all the steps will be taken. This is the whole procedure actually. Concept is this one. So this question is the first question. You have to understand it very well. So this is your function. Y is equal to x minus 5 to the power 4. So we'll do the differentiation as I told you. First differentiation has to be done. So we are doing the f dash x, that is the differential. So we're calling it as y. Y is fx. So dy by dx is nx to the power n minus 1. So 4 comes here, x minus 5 to the power 4 minus 1, that is 3. 4 into x minus 5 to the power 3. This is dy by d. Now when you put it as 0, the second step will be, the first step will be dy by dx or f dash x. The second step will be to equate it to 0. So 4 into x minus 5 to the cube is equal to 0. 4 cannot be 0, so x minus 5 has to be 0. 0 cube, because x equals to 5 will make it as 0. Left hand side as 0. So x minus 5 equals to 0, that means the equation will become, or the f dash x will become 0 at x equals to 5. So you got one critical point. What is that critical point? Only 5. So negative infinity to infinity, this is the whole number line. So you have to place this 5 in somewhere and then see what is coming on the left and what is coming on the right. So x equals to 5 can be the point of maxima, can be the point of minima. We don't know as of now. Okay. So x equals to 5 will make this f dash x 0. That is why we placed it on the x-axis, or we can call it as a real number 9. So x equals to 5. Any value which is placed here into 4 into x minus 5 to the whole cube. Let us place 3. So when you place 3, I am placing a value which is lower than 5. So you get, because it is cube, so negative will come as cube only. So you get a negative here. You don't have to worry about whole solution. You just have to have an idea that this 4 into x minus 5 will into a whole cube will give what value when it is lower than 5. So here evidently we found it to be negative. Then any value which is higher than 5. I am now taking the value which is higher than 5. Let us take 7. 4 into 7 minus 5 whole cube. Now it is very evident that 4 into 2 cube. And this, don't worry about the number. Just worry about the sign. So you got positive here. So from a negative infinity to 5 you got 9. From 5 till infinity you got plus. So I told you 5 is the critical point. And on the left it is negative, on the right it is positive. That is, you are going from lower part to the higher part, from negative to the positive. So when you are going from lower to the higher, that is negative to positive, that means you are on the minima. So this x equals to 5 is nothing but the point of minima. This is a local minima. We have to find out the local minima. At what point We got this by x equals to 5. But how did we get that it is minima? Because we are going from negative to positive. So this is this is the point 5, and at x equals to 5, which will make this f dash x is equals to 0. And if you want to find out the value of y for this x equals to 5, right? Then you have to place it in the actual equation. So this is the whole scenario. And as I told you, you want to find out the value of y at x equals to 5, which is the critical point. You have to place it in the first equation, which is the original equation. 5 minus 5, that is 0. 0 to the power 4 is 0 only. So the local minimum value is 0. Now these questions are now normal for you. All these questions are going to be done by the same concept. So we'll take the next here. X cube minus 3x it is. So we'll differentiate it first. So f dash x equals to 0 we have to place. X cube minus 3x is there. So we have to do the f dash x. Fx is equal to x cube minus 3x. I'm just differentiating it. All the steps you know by now. So it will be, and you have to place it as 0 also. Let us differentiate it first. F dash x will be 3x square minus 3. This is f dash x, and this has to be equal to 0. When you put this as 0, 3 into x square minus 1 equals to 0. 3 cannot be 0, x square minus 1 has to be 0. So x square minus 1 can be written as x square minus 1 square, which can be written as x minus 1 into x plus 1. Because a square minus b square is a minus b, a plus b. So x minus 1 equals to 0, x equals to 1. X plus 1 equals to 0, x equals to minus 1. So you get 1 and minus 1 as the critical point. The critical points we got when we can place f dash x equals to 0, that eventually gave us 1 and negative 1. So negative 1 and 1 we have placed or marked on a real number line. Now this negative 1 and 1, what are the left and right values for f dash x? There are 3 intervals here. So the minima maxima value will be at negative 1 and 1. And what will be the value of minima maxima? That minus 1 and 1 has to be placed in the original equation, x cube minus 3x. But let us solve this one first. I am placing any value which is lower than negative 1. So let us take negative 1, negative 2. So 3 into negative 2 whole square minus 3. Now these value has to be placed in f dash x, not in fx. Fx is only the value of y for x. So for the values plus and minus, just take negative 2. Now take any value between negative 1 and 1. Just place some value, say 0. 3 into 0 square minus 3, you get a negative. So you can place a negative here. Alright. Now coming to 1 to infinity. Any value which is higher than 1, you can place 2 here. I am just placing the value. I am not bothered about what value is coming. I am just bothered about this sign. So when you place the sign, you see that this is going to be a positive value. What value is coming, I am not worried about. But I know that it is going to be plus, a positive value. Now plus minus plus, that is at negative 1 you are going from higher to lower, so you are at higher, so you are at maxima. Minus 1 is the maxima, local maxima value. That is you are at plus, you came down to negative, that means you are at the higher point, that is you are at the maxima. Negative 1 is maxima. So x equals to minus 1 is the local point of local maxima, and the value of local maxima is simply place x equals to minus 1 in x cube minus 3x. Again x equals to 1. You are at the lower point, you are going higher, so you are at minima. So x equals to 1 is the point of local minima. So x equals to 1 is the point of local minima. And now when you have to find out the value of y for these value of x, which is negative 1 and 1, you have to place the value of negative 1 and 1 at x cube minus 3x, not at f dash x, but you have to place this minus 1 and minus 1 in x cube minus 3x for the value of local minima and maxima, because x equals to minus 1 is the x point. You need a y point also to mark it. You have x equals to 1 as the minima. What is the value of that minima? For that you have to place this 1 in the original equation. So now first I am telling you the local maxima point. I am placing minus 1. Now I am giving you the local minima point, which is the 1 I am placing. So when you place negative 1, you are going to get what? It's going to be 3 minus 1 is 2. This is the value of point of local maxima at x equals to minus 1. And what is the point of local minima at x equals to 1? So these are the value 2 and minus 2. So this function x cube into x minus 1 whole square, same thing we have to do here. There is no change, no catch, just differentiate this function, place it equal to 0. You get certain points, those are the critical points, mark it on the number line and just find out plus minus. So I am differentiating it right now using the product rule. First step in solving this kind of question is differentiation. That is the first derivative. So when I am taking this x minus 1 and x square common, because what you see here is you have certain values which can be taken common. We have already differentiated it. Now we are simplifying it. So I am just writing these two terms, and if there is certain commonality, we are going to take this to make it simpler to solve. So you have x square into x minus 1 you can take out. So when you take this as x square and x minus 1 outside, what do you get? 3 will remain, 1 x minus 1 will remain for the first term, and x and 2 2x will remain for the second term because already x square into x minus 1 has been taken common. So 3x minus 3 and this is 2x square minus 2x. So what do you get? X square into x minus 1 into 5x minus 3. So we eventually got 3 factors. So you are going to put it as 0 now. F dash x has to be placed as 0. So what do you get? X square into x minus 1 into 5x minus 3. So x can be 0, x minus 1 can be 0, which will give you x equals to 1. 5x minus 3 can be 0, it will give you x equals to 3 by 5. So you have 3 critical points here. 0, 1 and 3 by 5. Okay, 3 by 5 is nothing but 30 by 5. If you divide it, you will take 30 by 5. That will come as point. So 0.6 it will come. Some value at 0.6. So 0.6 is between 1 and 0 and 1. So you just mark 0 and 1. And somewhere after the middle point, that is 0.5, just mark 3 by 5 because 3 by 5 is nothing but equal to 0.6 something. Okay, now at the f dash x, please remember, in f dash x, try putting value which is lower than 0 and higher than 0. We are placing the values now in x square into x minus 1 into 5x minus 3. And we would like to know the sign only, not the value. We are not interested in the value. So when you place value which is less than 0, say -1, you will get positive. When you will place value between 0 and 0.6, you can place 0.5, for example, you will get a positive. When you put a value which is higher than 0.6 something and 1, what do you get? You'll get a negative. When you will place any value between 1 and infinity, say 2 or 3 or something, you'll get a positive. So all these value I have already placed in this function, and that is how I wanted to find out negative, positive, and I placed it over the number line. So at 0, it goes from plus to plus. So when it goes from plus to plus at 0, that this point x equals to 0 is the point of inflection. There is no increasing, no decreasing going on. So this 0 is the point of inflection. I hope you got the idea. So we have to check at 3 points, 0, 3 by 5 and 1. So first point is point of inflection. Negative also will give you the same reasoning. How about between 0 to 3 by 5 and 3 by 5 and 1? It went from positive to negative. That is, you are higher and you are going lower. That is, you are at higher. So this point 3 by 5 is the local maxima. Now you go to negative to plus at 1. So you were at lower previous to 1 and you are higher to 1. So you went up. That is you were at minima. So now first is inflection, second is maxima, and third is minima. Inflection at 0, maxima at 3 by 5 and minima at 1. Alright. Now what are the values of these inflection, maxima, minima? First you will place 0, then you will place 3 by 5 and then you will place 1. Okay, 1 is of course 0. 3 by 5 is going to give you 108 by 3125. Alright, and when you put 0, it will be 0. So 0, 0 and 108, 3125 are the values. So you have to find out the critical points and the value also of minima, maxima at the critical. So this is the whole solution in front of you. I hope you will be able to do it. This is quite straightforward right now if you understood the first question. Now x minus 1 into x plus 2 whole square. So this question might come because already we have done this kind of questions, but there may be a repetition of certain questions. So this x minus 1 into x plus 2 whole square, the basic thing in finding the local minima and maxima through the first derivative is to differentiate, is to find out the first derivative. So x minus 1 I am taking outside first, x plus 2 whole square differentiation is 2x plus 2, then plus x plus 2 will remain like that. Differentiation of x minus 1 is going to be 1. Now you can take x plus 2 common in both these terms. So it will be 2x minus 1 inside and x plus 2 inside. So it will be 2x minus 2 plus x plus 2. 2x minus 2 plus x plus 2. So it will be 3x inside and 2x outside because 2 is going to get cancelled. Now please remember, this is the f dash x. It is the differential. It is the dy by dx. So we have to place it as 0 because f dash x is 0. That means the curve is going to cut x-axis at these points. So x equals to minus 2 and x equals to 0 are the point of criticality, which is the critical point. So in the real number line, you have to place 0 and minus 2. So you have got 2 points, x equals to 0 and x equals to minus 2. Now let us mark it here. You have to start with negative infinity and at positive infinity, but this 0 and minus 2 has to be placed here. Now this function which we differentiated was 3x into x minus x plus 3x into x plus 2. Now just place say negative 3. When you place 3 into negative 3 plus 2, so you are going to get negative. That is minus 3 into minus 1. So don't worry about the value, just worry about the sign. So f dash x will be what? It is going to be positive. What about any value between negative 2 and 0? Just place negative 1 for example. What is the sign of the value you are going to get? You are going to get negative. So this is the negative sign. How about 0 to infinity? Place 2 say for example. 3 into 2, 2 plus 2. This is very evident. This is going to be positive. Place it positive now. So it went from positive to negative in negative 2 at negative 2. So you are at higher, so it is local maxima. At 0, you went from negative to positive. So you are lower and you went to higher, so you are at minima at that time. So minima means you are at local minima at x equals to 0. So x equals to minus 2, you are at maxima. X equals to 0, you are at minima. So what are the value of maximum minima is x equal to minus 2 and x equals to 0. Now place this x equals to minus 2 in the original equation, which is x minus 1 into x plus 2 whole square. Now I'm placing negative 2 in the x minus 1 into x plus 2 whole square here. So this value is we are interested in, not the sign. This is the actual value because we need the value of y for every x. So at x equals to minus 2, we got the value of y, which is 0. At x equals to 0, what are you going to get? It will be 4 into minus 1. So it's going to be minus 4. So these are the values at critical points, which are the point of maxima. So value of the maxima is 0 at x equals to minus 2. Value of the minima is negative 4 as at x equals to 0. This is the what whole thing is which is being asked, and this is how you're going to follow this, write this. I told you everything with my words, you have to write it also. Now this is 1 by x square plus 2. So this is fx, which is 1 by x square plus 2. And let us do the differentiation first. The first is f dash x. I just do one thing. I just take this x square plus 2 to the numerator. It will become negative 1 power. So my nx to the power n minus 1, that is minus 1 x square plus 2 to the power minus 2. And x square plus 2 differentiation is 2x. So this is minus 2x. This goes to the denominator x square plus 2. Okay. So now this whole has a very catchy explanation. X squared plus 2 whole square, you already know, can never be negative because it is square. Any variable to the power even will always be positive, whatever be the case. So minus 2x is 0 because the denominator cannot be 0. So it means x equals to 0. So x equals to 0 is the only critical point we are getting here. X square plus 2 we are not worried about. Minus 2x equals to 0. So x is equal to 0. So let us find out any value which is lower than 0. So I am placing negative 1 here. In the f dash x, see, minus 2 into minus 1 is going to be positive, and lower part I already told you it will be positive. So any value which is lower than 0 will give you the differential as positive. Any value which is higher than 0, let us place at say 1 or 2. I am placing 2. Denominator you don't have to worry about, it will always be. Numerator is negative 2 into minus 2 is minus 4. So it will be negative. So you are going from positive to negative, that is you are at the higher point, you are going to the lower point, that is you are at maxima. So this x equals to 0 is the point of local maxima. I hope you got the idea. Going from plus to minus is maxima. Now place this x equals to 0 in this original equation in order to get the y. So what is the value of the function at the local maxima point? Put x equals to 0, you get half. So the value of at maxima, local maxima or maximum is half. This is the whole thing you have to write. X cube minus 6x square plus 9x plus 15. So f dash x is equal to 0. We have to place. First we have to find out the f dash x. So I am differentiating it right now. I am taking 3 outside. You will get x square minus 4x. 3 is a 9. So you get 3. So you have to place it as 0. 3 cannot be 0. So eventually x square minus 4x plus 3 has to be 0. Now this is quite simple. You can make the factor. You can write it as x square minus x into x minus 1 into x minus 3. So this is very straightforward. You know already this one. But finally you have to place it as 0. So x minus 1 will be 0 at x equals to 1. X minus 3 will be 0 at x equals to 3. So you have 1 and 3 are the critical point. Now place 1 and 3 on the number line. Start from negative infinity, go up to positive infinity. In between mark 1 and 3. Now there are 3 intervals. Negative infinity to 1, 1 to 3 and 3 to infinity. So any value which is below 1, you have to place it in f dash x. So let us take any value. I am placing negative 1. If we place negative 1, you will get negative here. Again minus 3, so you will get negative positive. So the sign you need, you don't need the value. Again, let us take the value between 1 and 3. Now when you place 1 and 3, you get, say, place value 2. You will get a negative because 2 minus 1 is 1. And 2 minus 3 is negative, so positive into negative will be negative only. Alright, so you get a negative value here. So we get any value between 1 and 3 as negative. Any value which is lower than 1, you got positive. How about 3 and infinity? Let us place 4 here. 4 minus 1, 4 minus 3. I am very clear. I am just telling you that 4 minus 1, 4 minus 3, you have to properly place the value and find out whether the sign is positive or negative. So at 1, x equals to 1, you are going from positive to negative. You are at the higher point going to the lower point. So this is the local maxima point. X equals to 3, you are going from negative to positive. So you are at the lower point and you went to positive, that is you went to higher point, so you are at local minima. So x equals to 1 is the maxima, x equals to 3 is the minima. Now place this x equals to 1, that is x equals to 1 here. 1 cube minus 6, 1 square plus 9 into 1 plus 15. So you get 1 all this thing will come as 19. Now place x equals to 3 in the original equation in order to get the value of local minima. So you place x equals to 3 here. What are you going to get? 15. So at x equals to 1 local maxima, with the local maximum point is 90. At x equals to 3, which is the local minima, the minimum point value is 15. Okay. So this is how you are going to write. This is the solution in front of you, so that you can refer it. This question we are going to take in the next discussion. Till then, thank you so much and take care of